Hi everyone, thanks for joining. I think we have a couple of topics today. The first one is the seamless BFT. Jason, do you want to go ahead and share your screen?
Yes, let me get started. Okay. Hopefully everyone can see the share.
Yeah.
All right, so for this one, we're going to talk about the seamless BFD feature. So seamless BFD is a simplification of regular BFD to help, especially in the situation where you're doing segment routing monitoring and want to monitor many SRT paths. Plus, it simplifies the session establishment and teardown. So in comparison with like classic BFD, this is the classic BFD state machine. Seamless BFD has a much simpler state machine, and I'll describe basically the reasons why. I've got a little comparison here between the two. Compared to classic BFD, which runs practically the same logic on both sides of the BFD session, and the two sides effectively negotiate with each other. Things like timers, capabilities, as well as transmit back and forth information about whether or not they're receiving the BFD packets or not. Seamless BFD operates in a way such that you have one side which acts as the stateful initiator that knows about the various sessions that it's trying to drive, and the other side acts as practically a dumb reflector, where it's just established as a reflector session, and just any packets that come to it that match its configured discriminator value and its the correct SBFD UDP port and things like that simply get reflected back to the initiator. So you could think of it as like a simple, like if you were thinking of like pings, for example, this would be like just some one side drives it and the other side simply reflects it back. This allows the initiator to create sessions as it desires without that information about those sessions needing to be known to the reflector. The reflector can effectively handle unlimited sessions, whereas the initiator is limited to whatever capabilities it has in terms of state tracking and things like that. So to kind of describe the difference between what the initiator is doing and what the reflector is doing, as I described before, the reflector has a single global session. It's allowed, you can configure multiple sessions, but for the sake of simplicity, we'll just imagine that there's one with a well-known discriminator value there, whereas the initiator is going to have the per session state that's going to generate the packets, detect if they came back or not, and so on. Now, in order for this to work, the reflector has a specific behavior documented in the RFC that it needs to do, which is basically it's going to reflect the BFD packet back. It's going to swap the SIP-DIP. It's going to swap the discriminators. It may encode state like, or must encode state like, is the session admin up or admin down on the reflector, but the reflector actually doesn't do any stateful behavior in terms of tracking individual sessions that it's receiving. And that's a key part of the seamless BFD features. The reflector should have no per session state, besides that single global reflector session that it has. And so the idea is, if the initiator, for example, wants to track or monitor a bunch of different segment routing paths through the network, it can simply do that without configuration needing to be applied on the reflector for each of those sessions that would have to be created. And that's why it becomes very useful for segment routing. So before I go on to the PR, any questions about the feature itself?
Jason, I have a basic question.
Mm-hmm.
So I think the classic BFD typically is link local between peering links, and this one can go across multiple hops, right?
Yeah, so SBFD is likely to be used mostly across multiple hops. BFD itself does support a multi-hop mode and can be used for multiple hop as well. There's a couple knobs in the API to allow doing multi-hop and even doing like routing, but whereas the device itself routes the packet rather than the port being part of it. Now it's really nice for SBFD as well because we have the multi-hop flag and we have things like that. So I'll show you that on the API that we do have that. But yes, you can use classic BFD for a link, for lag member, things like that. Most likely for SBFD, you're going to be using it more likely to use it only in multi-hop.
Got it. And second question I have, I mean, you are using SRv6. Are you checking the state of the entire path, or it's the state of the end hop?
So it's effectively the state of the entire path, because this can be combined. In fact, the primary use case is to combine it. Let me hidden behind here. Let me see if I open up the entire file. The use case, one of the primary use cases is to be used for SRv6 with SRv6 in caps. So if you look, there is existing, we already for classic BFD added this some time back, but there is the encapsulation type SRv6. So you can, as part of the session creation, say, and this is just on the initiator side, say I want SRv6 encapsulation, and then specify the specific traffic engineering path that you want to monitor. If you didn't specify SRv6 encapsulation, you just routed the packet, then it would be like whatever ECMP, WC, whatever data plane decision the data plane decided would be the best path to get there. But a very common use case would be create multiple initiator sessions to monitor different paths. And then, if you're getting packets back on one path, but on another, then you would know that there's a problem with that specific path.
Got it. So the reason you would use SRv6 is to source route the packet on a specific path and monitor that, right?
Yeah, exactly. And often you would use this in combination with if you're actually doing SRv6 also as your forwarding path in the network. So now you've got tunnels that you're trying to protect. So if one tunnel is having a problem, you can make a control plane change to direct the traffic over other paths.
Got it. Okay, great. Awesome. Thanks.
Okay. So in terms of behavior, it's very well spelled out in the RFC. Of course, we're not going to go through on this call what the behavior should be of the initiator of the reflector. For the most part, the packet format is exactly the same as regular BFD. Go back to the actual state itself. So it actually turned out that the API required very, very little. It just required defining the reflector in the initiator session. The initiator, most parameters and APIs remain the same. The reflector requires will have a much simplified configuration. So in the MD file, I give some example, of configuring a reflector. Let me scroll up to that. That's the first one. So in the SBFD, so look at the MD file, describes a bit about the use case. But the reflector session is basically a reflector. It'll have some local discriminator value. This should almost always be used. In fact, I think most implementations only support hardware lookup valid. You're not going to always reflect it directly out the input port. You're always going to want to route it based on the reflected SIP. So one of the things that the reflector will do is it'll flip the SIP in the DIP, and then the SIP will be the path that it's taking back. Of course, there will be a local IP, the reflector's IP itself that the session is listening on. And then, you can create it for V4 and V6. Maybe V6 would actually be the more interesting case for us for SRv6 initiator session, which I have later. And then you have some optional parameters, but then you just create the session and then it's just sitting there. It's not going to be, indicating any kind of state callbacks or anything per session on the reflector side. And then the initiator has the more, the more complete level local discriminator for its session, the remote discriminator that's trying to talk to, both the SIP and the DIP, and also the transmit intervals that it's trying to configure. So it's got the more complete, and it should most likely be used only with multi-hop mode. I think implementations may only support multi-hop mode for SBFD. And then for the SRv6 encapsulation, I put an example of that as well. The main difference there is that it's the same as the previous. The only difference is encapsulation type SRv6, and then has the SRv6 encap and SID list ID there. SID list ID, I don't show the example of creating it, but it's basically just a list of SIDs that you'll be taking.
So basically at initiator, you will create session for each remote destination, right?
Yeah, exactly. So you can think of it, reflector, single session for all initiators. Initiator will create a session for every remote destination. And if it wants to monitor multiple paths to a remote destination, it'll create a session for every path that it wants to monitor as well.
Got it. Even though your dip, etc., may be same.
Yeah, the final dip may be the same, but the SID list, which indicates the path to get there, may be different.
I mean, that's the only thing will be different. Your local ID and remote ID will be same as well.
Mm-hmm. That's right.
Got it. Okay.
So from an actual API point of view, the only difference is this the creation of the two types. Now there's a bunch of metadata changes required because there's things like remote discriminator that would normally be mandatory on create for a BFD session, but they aren't applicable to reflectors. They are still applicable to initiators, but reflectors, the user would have no value to provide for items that aren't relevant for a reflector. So that's where there's some metadata conditions that I've added to for things that correspond to the remote item. But in terms of actual API, it's just the creation of these two types, and the behavior otherwise is well defined in the existing APIs cover the knobs that are there as well as the callbacks for if the session state. For example, if the packets aren't received on the initiator is only monitoring its own packets that it's sending. If it stops seeing them, then it'll transition to a down state, do the down callback, things just like a classic BFD session.
Yeah, on this condition check, I was not clear. The only reason you're adding because you want to constrain the remote discriminator for the initiator, right? This configuration.
Yeah, classic BFD or the initiator, because let's say you're on the reflector, you have no information about the remote discriminator. Now, if we don't want to put the condition, we could just say, well, the user should put 0 here. The main reason why this condition is needed is because otherwise this is a mandatory on create parameter. So the user is otherwise if there's any implementation doing metadata checking or the analysis itself is doing metadata checking according to these flags, then it's going to require that discriminator value and the remote UDP port or the local UDP port and the destination IP address of the packet. Basically, the remote IP address is provided, whereas the actual behavior of the reflector is that it's really just copying the incoming SIP to the DIP, and that's the expected behavior. It's not these would actually be configurable or meaningful configuration parameters on the reflector.
Got it. Okay. Yeah, no, I was just thinking now, since it's a full enumeration of the session type. So if you add a new one, then you have to add it here as well.
Yeah, we may want to think about having like a condition and not equal at some point. But that would have simplified this a little bit.
Right. We don't have a exception condition, probably not, right?
No, we don't. I looked for it actually because I did want to use it if we had it. Maybe it's an improvement option for the metadata library.
I think probably, yeah.
I mean, we would want to avoid more complex logic, like a mixture of knots and
correct
and equals. But
yeah, I mean, I understand the rationale behind adding it. It's just that, if let's say we go and extend the session type, then we have to make sure to add all these places as well.
Yeah, I agree.
Yeah. I mean, it's a little clunky. We can check with Kamil on it. Do you want to shoot the email? Just see.
Yeah, we can check. I mean, the other option is to remove the mandatory option, but and make it a create only property that's not mandatory. But I think that kind of removes some constraint checking that we have for the others, but we can check and see if there's a better way to do this. I mean, chances this isn't that, it looks kind of ugly, but it's not actually. I think
No, I agree with you. It's just it's not. I mean, and there is a chance of introducing an error. Somebody does not add this condition, but we will catch it. I don't think it's that bad. It just looks ugly. I agree with you.
I can check if there's another way to do this. And maybe you can tag Kamal on the PR and ask as well to see if it works.
Yeah, if there is no other way, then we can just go ahead with it. No, this looks good, Jason. Thanks.
Thanks, Jake. I think that's all I had for this one. Then, unless there are more comments. Okay, thanks, folks.
Thanks, Jason. Okay, yeah, the next topic is on the per traffic class enhancement. Praneeth?
Yeah, thank you, Tej. Let me share my screen. Let me know if it is visible. Yeah. So basically today we'll be checking per traffic class enhancements. So we are supporting two features as part of it. So one will be bump flood control per traffic class and another is TAM bind point support per traffic class. So basically this HLE will cover the broadcast unknown unicast multicast flood control per traffic class. Similarly, we also have, basically we are adding a new TC object, which will also allow TAM objects binding on that particular TC object. So if we see the existing behavior, right? So we have like bump traffic, we can either drop or we can allow per VLAN basis, which is VLAN flood control. And similarly, we can have like per port, we can use a per port policer to rate limit those bump traffic. So we don't have anything with respect to TC for the bump traffic. So basically now we are trying to add this flood control setting per traffic class. For TC level, we'll try to add this. A new TC objects we are adding as part of this. And additionally, like we are having a host type trap. Host type trap will try to derive the packet action for this particular bump flood control packets. So if we see like this is the host type trap which we're going to introduce. So this is like type TC flood control. The
Hey,
default tab.
Praneeth, sorry, you went just
Sure.
way too fast.
Oh, I'm sorry. Sure.
Can you go back all the way and just slow down on
Sure.
the rationale? I didn't even get what TC is. I
TP
know
is
the traffic class, right? But little bit more detail on this. Well,
yeah.
why, and so I
So
was not able to understand what you were saying.
sure. So basically, like we are having like per VLAN flood control, right? Like on a particular VLAN, we can ideally enable flooding or we can disable flooding. Flooding for the bump traffic, which is broadcast and unicast and multicast traffic. So similarly, I want something like per traffic class. I want to control whether I want to allow this bump traffic. So the traffic which is destined to a particular TC, I want to control whether I want to drop it. Let us take a simple use case, right? Say, for example, I have some lossless queues. Some TCs are getting mapped to some lossless queues. I don't want any kind of bump traffic on those lossless queues. So I have a flexibility of using per TC bump flood control. I can enable on it so that I'll not be getting any like unwanted bump traffic on the lossless queues. I can control it. I can give it to CPU or I can drop them. So that kind of control I'll be having if I have this feature.
So, okay, let me understand. So today you can have a traffic class which can map to any queue and
Yes.
may carry bump traffic, may carry regular unicast traffic, right?
Yes.
It can carry either one of them. Is that assumption correct?
Yeah, unknown unicast is what we are trying to control.
Right.
Yes.
So So the assumption here is that traffic class is carrying only bump traffic. Is that the assumption?
No, it may carry both like bump traffic as well as known traffic. So I'm trying to control only the bump traffic. Bump
Only
basically.
bump traffic. Okay, so
Yes.
you have a qualification for a bump traffic, and for a given TC
Yes,
that you want to rate limit.
that is correct.
Okay, okay. All right. Okay, I got a little bit of understanding. Okay, now go ahead. Next.
Yeah. So we are adding a new TC object. So as part of this particular TC object, I can have settings like flood control enable or disable. I can have another setting of binding a TAM object to it. This is one. And secondly, I have a host type trap. I can use this host type trap basically to derive the packet action. Basically, packet action is like whatever the flood control trap flooded packets are there, bump flooded packets from the TC, I can ideally say to drop them, copy them, or whatever the host type related trap actions I have, all those actions I can apply on these flooded packets.
Okay, let me just step back. So typically in a hardware, you have a rate limiter, right, for a given class queue, and that rate limiter, you can say that but that rate limiter is only on the queue, or it takes into account, a little bit loss of information on my side. Does it take
Yeah.
into account a
So
traffic?
this is not, so we are not going to rate limit anything. When we say flood control, ideally I can drop or copy, give it to CPU. So I'm not going to do any kind of policing or shaping.
So you're not doing policing and shaping. So your action is just a drop.
Drop or copy forward.
Copy to CPU, and that you are driving through simple ACLs, or
No, there won't be any ACL involved in this.
then how will you drop it?
I can use a host type trap over here. So that is the trap I'm going to introduce. That will try to drop the packets. The trap action, basically host type trap will give me the packet action. Packet action can be drop copy.
Got it, got it. But host type trap typically are also either used
Yes.
ACLs. Yeah.
Yeah,
Okay. So you're using host type trap, but then okay, and that will be then on the ingress side only.
that is correct.
Okay. Okay. Got it. Okay. Got it. Okay. And traffic, but ingress side, you don't have a resolution of the TC yet, right? You may have a remarking, and then your TC may get remarked for the egress.
So basically ingress based on the DSCP or .1p, I can map it to a TC. That happens in the ingress.
Correct, correct. But that TC will not give you a queue resolution yet.
Yes. So
So
mainly, yeah.
so
Please.
so yeah. So I'm trying to understand the use case. So you have a bump traffic. You are protecting a queue if it's a lossless queue, so that you don't take the unnecessary amount of bump traffic on it.
Yes.
But that's an egress queue, correct? An egress queue will get derived through some other map, cost map, TC map, or whatever, right?
Yeah. Yes.
But if you derive the TC object, which is the new object based on the ingress DSCP,
Yes.
you still don't have a resolution on the egress queue, right? Then how do you protect the egress queue?
So ideally, when I say so, like take an example, right? I'm having say 64 ports. Each port is having 2 lossless queues. So I have around 128 lossless queues. So instead of going and programming on each lossless queues in the egress side, I can just directly apply on the ingress TC, which will directly go and up, which will take effect for all the 128 lossless queues.
But then that's a big hammer, right? That may not be going on a lossless queue. What if that traffic is going on a lossy queue?
Okay, so basically the user must be aware which TC is directly mapped to lossless queues. That is assumption.
But it's not resolved. This TC is still not resolved, right? This is derived based on the incoming DSCP. You see what I'm saying? I understand what your argument is. What you're saying is that I do the flood control on ingress. irrespective of where it's going on the egress port,
Yes.
comma queue, right? And the
Yes.
argument is there that if then all the queues are configured in a lossy mode, then this flood control is important. And I'm making a counter argument that may not be true. And if it's not true, then what do you do?
It's okay. So
So Jay, sorry, I joined a little late. I had a conflict. I'm trying to understand the question, Jay. I'm trying to understand where the ingress notion comes in.
I mean, this TC object, the new object, which is derived from based on incoming DHCP, right?
Yeah,
That's
the
what
TC is DSCP to TC map is maybe it's applied on the ingress port, and we got it. Yeah, okay.
Right, and then this TC may not be still the correct representation or map for a egress queue.
Yeah. Jay, okay. So I think I little got confused by Q, Pranit. What you're saying is there's a feature on a per TC level you can enable or disable bump traffic, right? That's what is the goal here.
yes.
The goal is to enable disable bump traffic on a given TC. Okay, and that TC could be derived based on the switch level. The TC to Q could be different, right? It could be either on the switch level or on the egress port. The TC to Q mapping can be derived in different ways, but this feature is to do at the TC level, Jay. On a given TC, the TC is derived based on the incoming port properties, right? Either port or the logical interface. We derive the TC, and on that TC, we are just enabling
No,
whether
I
to do allow bump. Okay.
understood that part. I think
Okay.
the feature is trying to do the flood control for the lossless queues, right?
That could be one application of it. Yeah,
that could be
one application could be
right? Or you're trying to do it on any queue, whether it's lossless or lossy.
Yeah, that's up to the user. Exactly. This is on the user. All we do is at the TC level, we are giving that probability, the capability to stop bump traffic.
Why not install just ACL rules?
That's true, but the only thing, right? It's
I mean, you
there
have
are some native. Yeah.
Sorry, I was saying that you have incoming traffic class. It's available to your and various stages. You can actually drop it at a pre-ingress stage too. You know, it's a bump traffic at that.
Jay, true. Yeah, Jay, true. Counter argument is right. Everything can be, most of the features can be done via ACL, but there are some common use cases, right, which could have device capabilities, right? So we don't need to use an ACL for some common capabilities.
I mean,
This
you're
is one
using
such thing.
host type trap, so it's underneath. Most of the implementations use ACLs, right? It's just a different dedicated block, or may actually in some devices may, and some may just use the ACL themselves.
Yeah, I think this host F trap is just for one action. If you are trying to do, let's say, Jay, it's just going to for TC the action is drop. Okay, the host F is just going to say drop. It really doesn't go use an host F ACL entry. The host F trap I think was modeled here so that we can, when we have an action, let's say like a trap or a copy to CPU action for the bump traffic, right? If a user wants to monitor what is the bump traffic to debug. So in those cases, we wanted to associate with our safe trap so that the existing infrastructure comes in place, which queue it has to go, how to rate limit, all these things, right? That's the reason we want to use the existing host F trap. It doesn't mean internally we are always going to use a ACL, J. I don't think in this case we really need an ACL for all this, unless user wants to rate limit or do some other features with the host F trap, right?
I mean, you're doing your actions are drop or copy to CPU.
Yes. Yeah.
Those
Drop
are the
and if
and both are
drop.
available through the ACL rules, and it's a pretty. I mean, I'm just trying to, create arguing against it that introducing another object, which end of the day does the same thing, and it's bump traffic is a well-known traffic. You know what bump traffic is, right?
Yes. Yeah.
So
The
you
only question is, right, not see, generally most of these features can be done via ACL, but if there are some optimal ways to do without using hardware ACL resources, right, Jay, instead me going and wasting an ACL table to put this rules, right? If there's
But
some
drive trap is not necessarily not ACL. It is also ACL, no?
I think it depends on device implementations. I know some implementations in some of our platforms, right? They don't use
True, but that can be,
ACLs.
yeah, and this can be also done at a pre-ingress stage. So if you want to model it in a more optimal way.
Here, what you're saying is the underlying implementations can choose whatever. This is a commonly used case where we are seeing on the TC level, we want to drop a bump traffic, right? Today, that bump traffic control is set up port level with rate limit, okay? Or we can do on a per VLAN basis, right? So what was needed is a per traffic class level. Typically for just maybe for the lossless, right? The PFC and stuff, that was one example. This is a common, that's a use case, and different implementations can go and realize it using ACL or what was optimal for the hardware. Okay, and it's not necessary that all the implementations need an ACL entry, Jay. That's what I'm trying to say.
No, I understand, but that we do it even today, right? I mean, that's where we do the flood control of a bump traffic going to host CPU, right? Using host trap, even today. And the actions are same. You actually either let them rate limited or you can control certain class of traffic to be dropped, etc. And that's done today. And that's done at a very early stage in the pipelines.
Jay, today in SAI, I'm thinking in terms of SAI, right? I don't think we have a trap for bump traffic, something called a trap type for bump traffic. I don't think we have such a thing. And further, today, if you look at OCF trap, it has something called an exclude port list to say this trap should apply only for set of ports, some set of ports, right? Such a notion is not there for TCs, saying that hey, this trap should only apply for this particular traffic classes, right? That notion, both the things are not there today in SAI. I understand what you're saying. Your device internally today supports all this. They're saying you have a way to drop bump traffic from coming to a CPU. But in the SAI, there is no model to go and say either at a switch level, stop all the bump traffic, or even at a switch level on a per TC level, stop bump traffic, right? Such a capability is not there in SAI, even though it's a very common need, right? It's not there in SAI.
I mean, you have ACLs, Ravi, right? I mean, we install a one wildcard default entry, right, which is basically catching the bump traffic, and that's typically how. And it's not that you're burning anything extra. You have a slice which is already allocated. It is a one wildcard entry for the bump traffic, if you want to. And if you want to use it for a specific traffic class, that also is done. I'm not justified with this. I'm still not, and I'm trying to create a mental justification of it. And so far, I'm not able to bring myself that, yes, this is the right.
Jay, I'm just trying to say, right, Jay, many of the things can be done by ACL, Jay, okay? But we really don't need to do ACL for, ACL is like a more expensive TCAM usage, right? There are things that we can do without ACL, and that's one thing I want to tell. And even if you want to do ACL, right, Jay, there are a lot of match conditions missing inside today to identify the bump traffic. For example, Jay, I like to burn so many entries, right, to identify a bump traffic. Today, let's say, right, let's say there's a match field to say that did an FDB entry hit or not. That will be a different match condition. Then if the MAC address is 0xFF or broadcast MAC, right, that will be a different match condition. Okay. So we'll end up for multicast traffic, right? Again, we'll have to create one more match condition. So we'll burn so many aces to do this. It's not like a single wildcard entry, Jay. That's what I'm trying to tell. Even if you want to do ACL, right? And that is not an optimal way to do it. That devices can have some smarter ways to do it, right? If it has to be done by ACL, user will have to go create an ACL table and create these many ACL entries. Per TC, the user has to go create one entry for broadcast, one entry for FDB hit, not hit. Okay, they'll have to do an inversion that it didn't hit any FDB entries. So it's if you want to do it ACL, it's not straightforward, Jay.
You have to
programming
install.
model. The hardware is easy, but the high programming model is not. It's definitely not like what you said. Like one wildcard entry will do it. We'll have to burn multiple ACL entries
How do
per
you
TC.
how do you install? You still have to qualify the bump traffic, right?
Bump traffic is well known, right? The device natively knows that it's going to flood it. It's
No,
going
I'm
to.
saying in the proposal, when you derive the
Mm.
TC, you bind it to the bump traffic. How do you identify where do you do the binding of a TC to the flood control?
Yeah. Friends, maybe if you can scroll below.
Scroll down. Yeah.
Okay. The first thing is we created something called new TC object. Okay. Today, I think this is also missing inside. What we can do on TC today, right? That the object is not modeled. And I think we had the same discussion when we were trying to do some telemetry cases, right, Jay? When we wanted to do telemetry on a given TC across all the ports and all the queues, right? Then the suggestion was, instead of doing a switch attribute, let's go create a TC object. I think the original proposal, what Rajkumar did, I think, right? For the telemetry, we had created on the switch attribute a list of TCs on which the stamp should be bound. But then I think the feedback for all of us agreed is, right, let's go create a new TC object and put whatever is common on a given traffic class, bind it here, right? So that's what we modeled, something like a TC object. And this TC object will have a TAM binding. It will also optional, right? A TAM binding. It could have this case, right? The flood control knob. All this is on this newly created TC object. Friends, can scroll a little below, please. The attributes of this TC. Yeah, I think this.
So this attribute is basically to enable the flood control setting, and this would be to bind the TAM objects on the TC per TC. So we have again the TC we have TC index, which will be a key over here.
And host type trap flood control is a new attribute.
Yes, host type
No,
trap.
that is a new type. It's not an attribute. It's just a
Sorry,
type.
Yeah. And the qualification for that will be whatever.
Whichever packets go to on a trap on a TC, whichever has flood control enabled, a bump traffic coming on a TC which has flood control enabled, right, will automatically match this trap type.
Okay.
And then the user can specify what's the action needed. Should it be a drop or should it be an enable?
Okay, so you are basically, if your implementation is telling you that this is bump traffic, you take that along with that TC, right, and then create a host IF trap for it, right?
In the sense, Jay?
Aggregate hint.
Setting a hint. And then I could have one or more TCs saying that on this bump flood, on this particular TCs, disable flood control, enable the flood control feature, right? Bump flood control. So what is the action to be taken is defined by this host type trap TC flood control. So yeah, effectively like what you meant.
Okay, so I think I'm building the argument, right, as you are explaining. So first thing is that we are doing flood control irrespective of the queue, whether it's lossless or lossy, because that you don't know at this point, right? So that's the first thing, use case. I think that might be good to clarify that.
Yeah, we should do it. We'll do that. Yeah.
And the second is instead of using ACLs, you want to do a given implementation. If it has a host type trap,
smarter way of today. Yeah,
smarter
exactly.
way of doing it, then they should use this. And in this, there's an assumption that hardware gives you aggregate information for a bump traffic, which can be just used to create a trap.
Exactly, Jay. Yeah, exactly. That's the point I think we didn't stress properly. Yeah,
Okay.
We can do with the ACL, but ACL will be more match conditions, but hardware could have an efficient way to denote bump traffic.
Yeah, and I agree that there's some hardware have a different host type trap and so on and so forth. Yeah. Okay, I think so. I'm able to create reasoning for myself. I have to justify myself first, right?
Yeah, sure. Yeah.
So okay, I think that's reasonable. Let's go. Continue.
Yeah. So the TC object, what we have, basically it can be created anytime. And so we have existing QoS maps, like DSCP to TC. So all these things will be, it is independent of this new TC object is independent of all those things. So this is for backward compatibility. We are not touching, basically we are not correlating each of them together. So the existing TC Q maps, whatever is there, it will be coexisting along with this new TC object. Then we have basically switch attributes. The switch attributes will try to get number of TCs, and we can get the TC list also. This is read-only objects basically. So I given AP examples over here. So assume, say I want to create, so I can create a host type trap with a drop action over here. I can specify the counter IDs over here. I can just attach a counter ID over here. So basically I'll be able to, so the moment I want to enable flood control on TCID 4, I need to provide the TC index 4 and then enable this flood control enable as true. So I can once it is enabled, the moment it is enabled, it will start dropping the packets. So I can get the drop packet counts, the flood drop packets counts, basically by using the counter which I attach to the host F trap. Based on my need, I can disable by using a set operation on this flood control enable on this TC object. Similarly, I can.
Disable might be the default, right?
Yeah, by default it's disabled. Yeah, this is default, correct.
Okay.
And I can, as I mentioned, we can also bind TAM objects to the TC. So here is a sequence we created, so like TAM transport, TAM collector, TAM report, TAM event. And finally, we have TAM object. This TAM object we can go and associate to a TC, per TC. And similarly, we can read from the switch how many number of TCs we are having and the TC list we have created.
So question on this, on the 5.6 number of TCs and list. Ravi, don't we have this? I mean, today when you do the TC map, don't you need this information? Don't you get this information already?
No, Jay, today, right, we don't know TC as an object, Jay. It's just an index. It just uses the number. Today, right?
But
today in the cost map.
Cost map we configure, this need to map number of traffic classes, number of,
I think that is there, Jay. I think, right? Let's size switch chatter something is there. 1 second, right? The number of TCs, let me see, which is new here, Praneeth? The number of TC is new, is it?
Yeah, number of TC and number of TC lists both are new.
This is new.
Let me see switch attribute. Let me see the existing switch attribute, like
Ravi, max number of traffic classes.
Yeah, I think that is what we should have used.
Yeah, because it's a fundamental information we need it for our cost maps anyways.
Yeah, I think that's true, Jay, what you're saying, right? This should be switch chatter cost max number of traffic classes. We don't need
You don't need
the first one. The only second one maybe we can need. The first one is not needed. Correct. You're right.
Okay. I'll make this correction.
And retrieve why do you want to retrieve? Because the number might be different. The index might be different.
Not only that, basically, say for example, later point of time, I want to disable some setting. I can get the number of TCs. I can get the TC list, what has been created. And based on the list, I can pick and I can disable or enable the features on that.
No, I understand that. But why you need, let's say that number of traffic classes supported is 4. Shouldn't the list be 0, 1, 2, 3?
Jay, the list, the data type, I think, is a TC object. It's not a number. It's not like the TC indexes.
This is the TC object data type. Got it. I was thinking that you're reading the class index.
Yeah, I think this is just for convenience, I think, Jay, just for user to, if somebody does a discovery.
Correct.
Yeah, I don't think you need that a number attribute as a separate attribute, though, because what you would typically do with these list type of things, if you're using a list of objects, is you just first try to get to a 0. As part of the return, it'll tell you how many there are in the list. And then you don't need like a second attribute to track the size of the list.
Yeah, I think that's true. Yeah, we can get in the first empty, you send a list of size 0 and the count will be filled with, yeah, you're right, Jason. Yeah. Praneeth, I think we can reword this, right? You should reword this. Yeah, I think I missed this earlier. The
Sure.
first part we can do a two-step thing, right? First you send with the TC lists array size is 0,
Okay.
list size is 0, right? And yeah, I think that's correct. We can simplify all this.
Sure.
And just so I understand correctly, the idea here and the reason why this TC object is created is not, just for this feature, because this feature you could just go and create like a map of TCs to whatever flood control you want, but because kind of on a generic sense, you think there's value in having a global object for kind of global configuration parameters related to a TC. Is that right?
That's true, Jason. Exactly. Today, that's the reason we're not just putting flood control, water TAM we are adding, right? And we can add for other. It's a general purpose TC object.
I understand. Okay.
Yeah, today TAM earlier does it like you can set the DHCP, and then through that, derivation can happen of a traffic class. This is an explicit binding to the traffic class.
Yeah, Jay. The DSCP is there, Jay, for the INT as an identifier, right? To identify this particular row. Yeah, I think
No.
this is
When you generate the outbound packet, you can also modify or set the DSCP,
yeah.
right?
That's also that. Yeah.
Yeah,
For
that's
the whatever
one
new
way to do
reports
it.
or events. Okay.
Correct. That's one way to do it. Other way, you bind it to TC, and then you get aggregate behavior.
Okay. And Jay, just like today we have something, right? INT presence type as a DSCP or something to identify a flow of interest, saying that only for these particular types we need TAM to happen. Only for this particular packets coming on this TC, I want to do a event generation or something, right? Drop event generation, etc.
Oh, I see. You're thinking like that, not as the marking. Okay.
Not as a marker. Yeah.
Okay, not as a marking for doing any kind of shaping or rate limiting.
Yeah.
Okay.
Today, the way we have to do is we have to create an ACL entry match on the TC and then bind it to a TAM object. But
Right.
Yeah.
Yeah, no, I understood. I think that use case also probably you might want to a little bit explain in detail.
Yeah. I guess, Pranit, can you scroll? Maybe we can put more text on that, right?
Yeah, it's very cryptic.
Yeah. I think we can
Even
add
I
more.
forgot what we discussed.
And in fact, I would almost say it'd be worth having two separate ID files, one describing this TC object and its existence, and a second one that talks about the flood control as a feature, because the TC object itself is kind of a more generic,
More useful thing. Yeah, I think that's I think that's a fair point. I think we can so that right others also see the TC object. Otherwise, the TC object will be hidden here and nobody will know this. Yeah. I think we can make the the same pull request. We can make two MD files. Jason, that's what you wanted, right? I can create one pull in the same pull request. I'll create one MD file which will talk about a new TC object, and then there'll be another MD file which will talk about for TC flood control, and it will use refer to the previous MD file.
Yeah, that's what I'm thinking, because it's kind of like two features, one built on top of the other. You've introduced the TC object, and then now you're saying, okay, well, let's build this flood control on top of that almost.
Yeah, we can do. Do you suggest two pull requests or one pull request for this? Both are fine with us. Which way would be?
I'll defer to
Jay, your thoughts. So basically, we want to first introduce a TC object, a generic TC object, and then we want to talk about this specific case of per TC flood control.
Sorry, Ravi, are you asking me?
Yeah, your feedback.
Oh, my apologies. I got distracted.
Yes,
sorry, what you
Jay,
saying?
sorry. Jay, I think all this was fine, but what Jason was making a point is right. See, the per TC, creating a global TC object is a generic useful thing, right? And instead of embedding that into this particular feature, we can create a new document which just talks about this generic TC object we are creating.
Okay, I see. Yeah. So basically, you want one document which gives you an infrastructure of a TC object, and second document where the consumers of that TC object, which is TAM and BUM.
Yes, yeah. And so we have to create two markdown files. That is fine. Can we make the same pull request to make both the markdown files, or create two pull requests?
Jason, that should be okay, right? Right, Jason?
He deferred it to general community. So I think we'll try that only, Jay. We'll in the same pull request, we'll make the two different MD files and make sure The second first MD file talks about only the TC generic TC object, and the second MD file talks about how to use a TC object for thread control and give a reference to the other one. I think
Yeah.
we'll do that.
Let's do that. And Ravi, this one I need to get a little bit more review done on this. So once you are done the restructuring, give me some time to get it reviewed.
Yeah. Pranit, I think we'll update the PR. Okay, put this notes in this whatever we discussed, right? Put the notes here, and then you can send an email to Jay about this, right? That your update done with it. Yeah.
Sure. Okay. Ravi.
Thanks. Yeah.
Okay.
Sure.
Thanks. Thank you,
Yeah,
guys.
that's it from my side. Thank you.
Okay. Yeah. Any other questions for Pranit?
This is hello
Yes.
everyone.
Hi. Yeah. Go ahead.
I'm Ali from Explore. Basically, our team is interested in contributing to the SCI. However, we currently don't have access to any SDK. So, can community please guide us whether it is possible to contribute for us in SCI?
Ali, I think at least I was not able to get completely what you're saying. You are saying that you don't have SDK and you wants to contribute to SCI. Is that what you're saying?
Yeah, exactly.
I mean, what do you mean by you don't have SDK? Do you have a hardware?
We have switch basically.
Okay. I mean, see, you can contribute, but contributing to a SCI without having a underlying SDK API will create problems for you because SCI is a logical abstraction, right? And if you recall just our discussion, to the previous PR, we were trying to map that to a given hardware implementation, and we do it like pretty rigorously, right? Where whatever we define need to work and map on some underlying SDK APIs. So if you do that, right, you probably will create trouble for yourself when you actually define the SDK APIs. So proper thing to do is understand your hardware behavior, see what underlying APIs you want, and then create a logical abstraction, which is generic, and then bring it to community. But if you have something you want to bring, I think Tejaswini can add as well. We are pretty open to, having a discussion, as long as it makes sense to all. That's as long as that feature which is applicable to most of us, if not, all of us.
Yeah. Okay.
Right.
I got it.
Yeah.
Okay.
Yeah, you can go ahead and make the proposal. Yeah, create a PR and we can discuss it here.
Thank you. Okay, thank you.
Okay, thanks everyone.
All right, thank you.
Thank you. Thanks, everyone.
Thank you.